Now let's take up question number 16. This question states that prove that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. After proving this, hence evaluate integral 0 to pi of x sin x upon 1 plus cos square x dx. And this question carries 4 marks. So let's proceed with this question. Very first, I will be proving that this is equal to this. So I take up the right hand side to prove this expression. In right hand side, I have to obtain integral from 0 to a of f of a minus x dx. Now let's consider here that a minus x is equal to t. Then differentiating both sides with respect to x, I will obtain minus dx is equal to dt. So let's substitute here a minus x with t and substitute dx by minus dt. These limits will also change according to that. When I consider x as 0, respective value of t will be a, and when I consider x as a, the corresponding value of t will be 0. So taking this into consideration, here when x is 0, then in that case I get t as a, and when x is a, t is 0. According to that, the limit is changing from a to 0. Here I have f of t minus dt. Let's proceed with this. So now, as you are aware, when you have integral of a to b f of x dx, and this is definitely equal to minus integral of b to a f of x dx. That means if you take minus common, the limits change. Here upper limit was b, here it is a. Same thing will happen over here. I have here minus dt, so this limit will change from a to 0 to a. Now in this case, as we know that integral of a to b f of x dx is definitely equal to integral from a to b f of t dt. So taking that into consideration, I can simplify this and write it as integral of 0 to a f of t dt is definitely equal to integral of 0 to a f of x dx. So in this way, we have proved this required condition. You can see here, I have already proved this condition that integral from 0 to a f of x dx is definitely equal to integral of 0 to a f of a minus x dx. So I hope it is clear to you. Hence we have proved this condition. Now let's evaluate integral of 0 to pi x sin x upon 1 plus cos square x dx. I am considering it to be integral I. Let's consider it to be equation number 1. Earlier you have proved the condition that integral of 0 to a f of x dx is equal to integral of 0 to a f of a minus x dx. Applying that very formula over here, I obtain that x will be substituted by pi minus x. When I substitute that, I get here, instead of x I have pi minus x, here I have sine pi minus x, and here I get 1 plus cos square pi minus x. As you know, cos pi minus x is equal to the value minus cos x, and square of that will give you cos square x, while sine pi minus x is sin x itself. So this is the equation number 2. Here in equation number 1, you can see right hand side is x sin x upon 1 plus cos square x. In equation number 2, I have on the right hand side integral with the same limits pi minus x sin x upon 1 plus cos square x. When I add up these two, here sin x upon 1 plus cos square x dx will be common, and on simplification you will obtain x plus pi minus sin x, where x will get cancelled, and you will obtain the value pi sin x upon 1 plus cos square x dx with the same integral limits, that is from 0 to pi, and on the left hand side you will obtain I plus I 2i. So let's add up here equation 1 and 2, and this is the resultant obtained. Here you can take out pi common, so this is twice of integral I equal to pi times integral from 0 to pi of sin x upon 1 plus cos square x dx. Now in order to find the integral, let's consider here cos x equal to t. If I consider cos x equal to t, on differentiating both sides I obtain sin x dx is equal to minus dt, or you can say minus sin x dx is equal to dt. So here sin x dx is equal to minus dt. So if I substitute here cos square x by t, this will become t square, and I have here 1 plus t square in the denominator, while here sin x dx will be equal to minus dt. Coming to the limits, when x is 0, t is equal to 1, and when x is pi, t is equal to minus 1. So this will reduce to twice of integral equal to pi times integral from 1 to minus 1 minus dt upon 1 plus t square. And you know that when you take the integral from a to b of f of x dx and you put a negative sign, to eliminate the negative sign you can interchange the limits. So here we have integral from a to b f of x dx. This is definitely equal to minus of integral of b to a f of x dx. Now in this case you can see I have eliminated this minus sign. I get here pi times integral from minus 1 to 1 dt upon 1 plus t square. When you observe this condition, here this helps you to recall the formula of tan inverse x, because integral of dx upon 1 plus x square is tan inverse x. So taking this into consideration, I can say that I obtained here this one as integral equal to pi by 2 tan inverse t, having the limits from minus 1 to 1. Here I have transposed 2 to the right hand side. I get here pi by 2 and integral of this is tan inverse t from minus 1 to 1. Now substitute the limits over here. That gives me tan inverse of 1 minus tan inverse of minus 1. Tan inverse of 1 is equal to pi by 4 and tan inverse of minus 1 is minus pi by 4. So I get here pi by 4 minus pi by 4, that is pi by 4 plus pi by 4. So this simplifies to pi by 2. Pi by into pi by 2 gives you the value of this integral equal to pi square by 4. Therefore you can see that I have obtained the value of this integral equal to pi square by 4. So in this question we had two parts. In the first part you had to prove that this left hand side is equal to the right hand side, and when you have considered a minus x equal to t and obtained this value by interchanging the limits, till this step you will obtain here 1 mark, where we have interchanged the limit according to f of t minus dt. Next, when we have proved this whole condition, you will obtain rest 1 mark for this question. And when you proceed to the next part of this question, where you have to evaluate the value of integral of x sin x upon 1 plus cos square x dx, having limits from 0 to pi, and you are adding up their equation 1 and 2. At this step you will obtain 1 mark, and later on when you prove the required condition that this integral I is equal to pi square by 4, we will obtain the rest 1 mark. So that gives you total 4 marks for this question. I hope this question is clear to you. Let's proceed to our next question.